Okay, so we're here to talk about discrete random variables or discrete random distributions. So let's just have a look at what we're talking about. So this is part of the probability distributions topic. Within that there's two types of distribution. There's continuous, which are on the right here, and you can see they're solid shapes, and we don't talk about individual values with them. Whereas with discrete distributions, we tend to talk about individual values, or we can talk about a range. So let's just zoom in on that. Now, the techniques I'm going to show you in the first part of this video can be used on just any discrete random distribution, or we can, which includes Poisson and binomial. Okay. So let's just have a look. What if we wanted to calculate the mean, the mode, or the median for this? Let's start with, well, first thing we want to do is label all the bars with their probabilities, and you should be able to read that. Now, this information could be given to you in a table, in which case it's even easier. So, what is the mode for this one? Well, what's the mode mean? The mode is the most common value, right? So which is the most common value there? Hopefully you can see that it's 3 because it's the highest bar, right? It's the most common value. It happens about 0.25 of the time. So that's easy. Highest bar, that's your mode. Bang. You can use this in exams. Hopefully they ask you a question and you can use it. Okay, so the mode's 3. Right, what about the median? What's the median? It's the middle when they're in order. Well, it's a bar graph, so it's already in order. So where is the middle? Not the 4 because it's, the middle bar, but the middle in terms of saying half the values are above, half the values are below. Okay, so let's just have a look here. Maybe the median could be between 1 and 2. Now, does that look right? Well, on the left we have 0.13, and on the right we have 0.87 if we add all those probabilities up. Obviously I didn't do that, I just knew that they have to add up to 1, and on this side I had 0.13, so obviously the other side has to be 0.87. You could check, make sure that this question actually works, but that's not the answer, is it? So what about here? Right, on this side we would have to add together those first two bars, right? So 0.13 plus 0.2 gives us 0.33, right? So we've got 0.33 on that side, and therefore we must have not 87, we should have 0.67. Sorry, typing mistake. Right, so still not up to halfway. So if I go on to this one, how much would I have on the left there? So I had 0.33 plus, so we're going to have 0.58 and 0.42. So we've actually gone just a little bit too far. So if the median can't be between 2 and 3, and it can't be between 3 and 4, then logically it must be at 3, right? And it doesn't really matter, that somewhere within 3 you can split it so that you've got 0.5. So all you care about is that the median's 3. So all we're doing is we keep going until the first score that we get up to where we get at least 0.5, and bang, it's going to be in that value there. Okay, so very good. Right, what about the mean? How could we calculate the mean here? Well, what we do normally is we add all the values together, or one way we could do that is we could take each score and multiply it by how often it happens, and then add them all together. Now, we often call that an expected value. Okay, so you remember your expected value is each score times by its probability. Okay, so here we do all that, and you can type that into your calculator while you pause my video, but I'm not going to wait for you. Okay, so if you want to pause me, go. Otherwise, I'm going to tell you that's the answer, right? The mean for this is 3.32, and if we look at where, that sort of seems like a fairly reasonable sort of an answer for a mean when we look at the graph. Yeah. Okay, so Now the question may ask you to compare a discrete random variable for which you've got your results with a Poisson distribution or a binomial. I'm going to show you against Poisson. It's a bit simpler to go through at first, but binomial is much the same process. Now, one thing to know about Poisson distributions is what they tend to look like. So technically I should really have bars here, but at least it's got the dot showing that it is discrete values, because you shouldn't really talk about in between those dots, but at least it's joining up with straight line. Now what you notice here is that there's actually a bit of skewedness. There's a bit of skewedness on the red one where lambda is 1. Okay, it would be even more. Lambda could be half, it would be even more skewed there. Okay, and then the green one is slightly right skewed, and then the 10 looks pretty symmetrical. Actually, it's still got a little bit of skew on it, but basically what you notice is small values of lambda have more right skew, large values of lambda mean more symmetry. Now a Poisson is never left skewed. Binomial can be if it has a large value for p, but basically a Poisson is either right skewed or fairly symmetrical. Okay, so small values of lambda, it's going to be quite right skewed, so that's something to look at. Okay, so here we look at this. One thing we do notice is that it is right skewed, so that's consistent with Poisson. Let's have a look at some more. Okay, so comparing features, it's right skewed. Now what should we compare it to? Right, well, the mean is 3.32, so we could compare it to Poisson with a lambda of something close to that value. Okay, so we might compare it to 3.3 or 3.4, or I'm going to go with 3.2, partly because that's just the way I prepared it. Maybe that could be in the question or something. Right, so let's have a look. How does this compare across? Right, so let's look for the highest value, because that is our mode, right? So if we look here, the highest value is that's for 3. Now that's the same as this is the Poisson, remember, that we're looking at in the table. So we're comparing the Poisson has a mode of 3, and the discrete random variable has a mode of 3. So that's something where they're similar, and you can comment on that. Okay, what else have they got in common? Let's see, where are the values quite similar? I'm thinking with x equals 1, that's almost the same. X equal to 2, that's almost the same. 3 is a bit different. 4, same, different. Call it same. Okay, well, fairly similar, right? Not the same. So yeah, these two same-ish. Those ones are the same. Remember that these are just the results of an experiment. We don't expect them to be exactly like the distribution that we're comparing it to. And obviously, even if we use a model for a distribution that's not necessarily going to be exactly the same, is it a good fit? Is it a bit like it? Okay. Now, one place it's very different is from, well, when x is 0, right? It doesn't happen at all in our discrete random variable. And from 8 on, obviously we've got zeros again, whereas the Poisson carries on there. And in the middle it's a bit higher, so yeah, a bit different there. And because our discrete random variable doesn't have values for x is 0 or x above 8, it has a lot less spread than a Poisson. Okay, so our results, our discrete random variable has much more spread. Now, finding the median. So what I do again, I start from the bottom score and I just keep adding on until I just get as little as I can past 0.5. So adding that on, yeah, no, that's right. Then add that one on. Okay, I think the next one, yeah. So it's not more than 3 and it's not less than 3, it must be 3. Okay, so 3 is our median for this Poisson. That was also the same for that distribution we were looking at. Okay, yeah. So here are the points that we've picked up. The means are nearly the same. They're actually a bit different, but yeah, they're pretty close. The mode and median's exactly the same for all of them. So the mode for both is 3, the median for both is 3. They're both right skewed, and some of the values of x have quite similar probabilities. The differences, the discrete random variable we were looking at had less spread than the Poisson. Our results had a slightly higher peak, and some of the other values were very different. Now, if you were doing a comparison in a test, we certainly wouldn't expect you to come up with all 7 of those points, but if you can get up to 1, you're going to get some credit. If you can get up to 3, you might be looking at some points towards excellence even. So, yeah, it's just a matter of seeing what you notice. Okay, very good. So you can look at individual probability values, you can look at mode, median and median, and look at the shape of the graph. Okay, so why are we doing this? Well, in the world there's the true probability of an event or events, right? But we don't get to see that. Okay, so what we do is we make assumptions and we come up with a model. We say, well, look, this is a Poisson because, and you can go to my Poisson Distribution video to find out what the assumptions you need to make are. It was something about Sir P being my cat, so events cannot happen simultaneously, events happen independently, the events happen randomly, and the probability of events is proportional to the length of the interval. Okay, go into that in way more depth, go see my cat video, it's really great. Okay, so once you made those assumptions, you say, well, is that right? Okay, is it right? So what you might do is you might do an experiment. Now, of course, the experimental results come straight from the true probability, don't they? But they're not going to be exactly the same, because if you do the experiment different times, you'll get different results. But apart from a small amount of sampling error, they're going to, in some way, look like the true probability. So what can we do? We've got a model, and that tells us one thing. We've got experimental results, they tell us another thing. So what we're really looking to do here is just make a comparison and say, look, neither of these are going to be exactly like the true probability, but you're basically looking at that model and saying, does it do a good explanation of the experimental results? If it does, we keep the model, we can make predictions from there. Okay, so I hope you enjoyed this video. Feel free to watch my other videos, and well, it's probability, but let's just say good luck for your exam. Okay, peace out, bye.